Yeah, thank you so much everyone for joining. Thank you, Deepthi ma'am. Thank you, Rajesh sir. Thank you, Ramalingeshwar sir. Thank you, Rohit. Okay, great. Yeah, so Rajesh sir, today's topic we are covering regression. So now I would also want to first guide people who were recently joined, right? So the members who have recently joined, uh, let me actually show you the way how the hackathon works, right? I'm just going to share my screen. Let me know when you're able to see it. Great. Okay. Amazing. Now, so if you see, all this is how your teachable will look like. And people who are in bronze, they will have access to bronze courses. People who have silver, they'll have access to the relevant lectures, and the gold people will have those relevant lectures here. Now, what we are planning to do in all the hackathons is revise each and every concept that was covered by the primary faculty in the session, right? So now if you look at the first module, second module, each and every module lecture, the primary faculty either here for AI, Jain sir himself or Rajiv sir might have taken those sessions, and we are going to revise that, right? So if you have recently joined, you can either choose to start from the beginning and also join the revision hackathons, or if at all you want to just go with the actual flow, and whenever you have a query, you can always join the hackathons and bring your queries, right? So we'll see wherever is the roadblock, wherever you are finding challenge, we'll guide you and help you there, right? So in today's session, we are going for 4.3, which is the regression. So now, if you want to access the lecture, you can start from here. And if at all you want to access the notebook for that particular lecture, you can click on the links that are given on your Teachable, right? So I have the notebook open. I'm just going to share the link to the notebook with everyone, right? Okay. Let me go ahead. Okay. Now I'm just sharing the link to that on the chat, right? Okay. So Deepthi ma'am says it faced a problem in the assignment extracting the mean age and standard deviation of hours per week from summary statistics of numerical columns. So, ma'am, you might want to let me know which module, sprint, or topic that this assignment was, and you can share it with us, and I'll come back on that. Right. So I'll also have to look into which session or which assignment you are in. It's in the beginning one. Okay. Cool. So what I'll do, hey Ritesh. So what we will do is we'll continue with the current flow. You also catch up with what is going on here, and we'll come and reach your question once again, ma'am. Right. So because now you have given me just a snippet of code, I'd want to see the whole context, all the what is the problem statement, and also it will become easier for me to answer this. I hope that helps, ma'am. Great. Okay. Amazing. So let's go ahead and let me just repeat because we have new members on the hackathon. So how the hackathons go? Hackathons are a way to revise all the concepts that are covered in the primary lecture. So I request you to either start from the beginning if you have recently joined, and continue to join the revision hackathons. If at all you plan on going with that particular flow, and whenever you come across any issue, you can come back onto the revision hackathon and share your issues. So do not worry. Right now we are in 4.3. Once we finish module 6 and a little of the challenges there, we'll start from beginning once again. So the revision hackathons happen in a cycle. Whether me or other faculty will be taking the same sessions. Okay, great. So I've shared the link. I'm going to share it again because more people have joined in. Now you can open the same link and we'll all be on the same page. I request you to run all the codes, all the cells along with me so that it becomes easier. When we run the code, we run into errors, and then that is when the stronger recall will happen. Okay, great. So in our previous session, we have seen the linear regression 2, where we have made our models, we have trained, broken our models into train and test data, and given the train data to create a fit for the model, and use the test data to make a prediction, to test data to also check if the model is fitting properly. And then we have also predicted what could be the outcome based upon the actual data given, right? So now in ridge regression, what we are going to do is we are going to see what happens when we have a little different type of data. So what, how do we go forward in that particular case, right? So I hope everybody has the collab file open. Now let us begin. So today's agenda, we have do this encoding called one hot encoding of categorical features. Then we'll also look at univariate feature selection, right? So feature is whenever you have a data, when a data set, each of the column which is going to affect the model is also known as the feature, right? So this feature selection is also something that we'll look in today's session, right? So we are going to break the actual lecture that is on ridge regression, which is of like roughly 1.5 hours. We're going to cover the portion of it and then pick up the balance from in the next session. Okay, so first let us go ahead and do the setup for it. We'll also learn to use again this scikit-learn, and we'll also from that use the fit regression models, right? Okay, so now what do we do? How do we get the data? If you remember in our previous session also, we started doing this where first we had the data path in one variable, and whenever we are reading the CSV file, we are concatenating that with the file name, right? So what this will do is, for example, this is the file name. You are going to get the whole data path. This is just like there's no heavy logic here. It is just going to be easy for you to always work with files in a better way. So when you concatenate these, and when you give this as an input to the read CSV, you're going to get that data into the data frame, right? So all of this is going to come into your data frame. We have named our data frame as DF here, right? So now what we are going to do, we are checking the shape of this particular data set. Okay, so if you see the df.head, now you can see it has multiple columns and multiple rows, right? So there are 34 columns here with 5 rows because we have asked for the head. Okay, so now if you see this particular opening that we have done here, what has been done? So in the same data frame, you can see that there, wherever the price column is there, in that price column, a little of update has been done. Wherever the top 0.5% of the percentile, 0.5%, the 5% of the data, whatever we have, the price, and wherever the bottom and the highest, right? So the first 5% and the last 5% has been chosen, and we are kind of dropping those from the actual data set because these are outliers. Most of the times what happens is the first 5% and the last 5% are going to be the outliers. We are kind of trying to remove the most extreme prices out of this by using this particular way. So even latitude and longitude also have these outliers. The beginning and the end portion we are cleaning to have a better data set for working, right? So if you understood what this step was doing here, if you understood that, type U in the chat box. Thank you, Ritesh. Right. So what I'm just going to clarify. Yes, Venkateswar. Yes, Vinpa. Okay. So in this data frame, we have chosen wherever it is in the first 5% and the last 5% of price, of latitude, and of longitude. All of that has been removed, and the data frame has been updated. Right. So now, if we are looking at one column, which is the we are creating DF created, there is already a DF created column. If you see, out of that, you can always use this to work with the data sets like date column. Whenever you have a date timestamp, you can always use it to filter your data, like sort your data based upon the recency and the age of that particular observation, right? So now what we are doing is, for our model, we are going to have two data frames, train and test, right? So now, last time what we have done in our previous session is we have trained based upon one value, which was, let's say, if it is less than 2008, it is training. Over 2008, it is test, right? So similarly, what we are doing here is 2016 June, we are selecting that as a cutoff date, and all the data, all the observations that are less than the cutoff date are coming into the train, and whatever is higher, like whatever observations were with date over June of 2016 are coming into test, right? So like yesterday, we had a question from the members only: is it always 80-20? Sometimes it could be based upon a select value like this as well, right? So now we have two data frames which are subsets of the actual data frame, right? So we have train and test, right? So this is what we have done here, which we will use for our model creation, right? So now this is how the data set looks like. And if you try to understand what this data set is all about, all the details are also mentioned here, right? So it is more of something related to apartments, only the address of it, and what all other features are there for that particular apartment, right? Outdoor space, wheelchair space, garden, and all those things are being mentioned here, right? So now what we are seeing here is some columns are numeric, right? So because we are kind of at this moment trying to work with category encoders, right? So we are trying to exclude wherever the features are numbers, right? So we are just trying to work with categorical data. So for that, what we are doing here is if you remember the train dot describe. So let me just so what this train dot describe will do, it will tell you all the it will describe the most important features out of this, right? So these many rows and columns have been listed, but if at all in that train data set we say exclude equal to number, now you can see that it is going to, where are we removing the outliers in percentile? Yeah, so now, ma'am, what happens is whenever you see these data frame things, when you give this as an input to the data frame, it gets updated, right? So, yeah, Ritesh, it's not like time series modeling. Here we have taken, one set of cutoff for, training and testing data set. That's not specific, right? So it's not the time series modeling as is, right? So ma'am, if you remember, whenever we have data frame and the square brackets, and whenever you give a condition, right? So what you are saying here is, in this data frame, include all things greater than or equal to these price in the after 0.5%, like after 5%, meaning all that is less than 0.5 is not being taken. Similarly, take everything that is less than or equal to 99.5%. So meaning it is starting from 0.5 to it is going till 99.5%. This condition itself excludes the beginning 5% and the closing 5%. There is no as such a drop function that we are doing. We are just having a condition and combining those conditions with the and symbol, telling that it should be the price should start after 5% and it should end before the 5%. So I hope this clarifies the question when you come up. Yes, we are getting the data in the specific interval. Great. Thank you so much, sir. Yeah. Now, if we see, if you have seen all of that data sets, now if you see here, when you have the describe, including the number, now you can see these columns alone came in where there is street address, interest level, display address, description created, right? So now out of that, each of these has some unique described stats, which is the count, top, least, first, frequency. All of this has been listed here, right? So now what we are doing here is we are using this dot t whenever we had the dot describe exclude number. To that we are doing dot t sort values by unique, right? So now what this dot t does is it transposes that particular data set, like the columns and rows get exchanged, right? Now if you see the count, unique, top, all these became the heading and these became the your row headings, right? So this is what has happened. All the data is same, just what happened is it became a little more easy for us to assess, right? So the same thing is done here. You might want to sometimes use this dot transpose and sort by unique values, right? So this is what is happening. Now, whenever unique is there, because we have sorted by unique, starting from the least, going till the highest, right? Now, if you do the trained or describe with including the number, so it will give the inputs of the number or numeric data set, right? So it is easy to work with numeric data sets, right? So categorical is the challenge, right? So sometimes because NumPy works with numeric Python, so it's always good to work with numbers. So it is one way to include or exclude your number type of data type, right? Yeah. Hello, Ramling sir. Yes. So I think your question or the confusion comes where we have seen those graphs, right? So where we were trying to get the portions where the first whenever we are doing the t-square graphing, we remove the 0.25 and the ending 0.25. That is a different case, sir, right? There we were trying to see our threshold. It should be the whole of the threshold should be less than 5% or higher than 5% to verify the null condition, right? So we were trying to see the p-value is less than the 5%. In that case, we use that, but it is not there. We are not saying it is an outlier or not, right? I think I understand that data framing was to validate the null hypothesis or not. We used to use that p-value and see if it is less than 5% or higher than 5% to accept or reject a null hypothesis. But outliers are something, right, based upon here, whenever you sort data, initial or ending, it is something that we can see based upon the data. So this has nothing to do with the 5% thing that we have done for accepting our null hypothesis and accepting or rejecting, right? So both of them are two different cases. But the confusion is genuine because there we excluded the beginning, and there we are not excluding, but there we are seeing most of our range, the mu or sample should always be in between that 95%. So that was our goal there. Here our goal is not that. We are trying to clean our data. So for that reason, we are removing the first 5% and the last 5%. I hope that is clear. Thank you so much, sir. Okay, so members who have recently joined, there was a reference to one of our previous sessions. Do not worry. If you start from the beginning, you will do catch up, and these questions can always come up. You can always bring them to the hackathon session. Great, thank you so much. Right. So similarly, now we have used the describe in combination with exclude numbers and include numbers and got the assessment of the count, mean, and all. So these exclusion and inclusion criteria can come handy many times, right? So now similarly for that also we can go ahead and do the transpose whenever required. And now what we're trying to do here is, there is this one value. If you see in the exclude number in the transpose, there is this interest level, right? So this interest level is non-numeric data, right? So when we have excluded, and it has 3 values only, meaning it is okay. I think Ritesh, we are all aware of NaN. Let me also see. Not a time, it seems. Okay, I'm not sure. I'm just searching along with you. Great. So let me just go if that see if that makes sense. First and last of time, right? So because created was a time series, I mean it had the timestamps. Maybe there are a few empty places or some data types different from the timestamp, and that is where it is showing that it's not time. Okay, it's a not a time. Thanks for that. I know I was also not aware about that. Cool. So what we are seeing here is the interest level here is unique is 3. Now display address, we know that there could be a lot of different address, and that for that reason the every other address can be unique. Street address is definitely unique, description is definitely unique, and the timestamp is also there. Everything is unique itself, right? Some timestamps might be same. But now if you see the interest level, there are 31,844 observations. Out of that, there are 3 unique types, meaning it's a categorical data. It is either like it's like small, large, or something like that. So it's going to be something unique. And now you can see from this data set, okay, interest level is something that could be used for our assessment, right? So now let us go ahead and look at the interest level. Right? So did we understand, like if you are clear with what we have got out of this interest level, it being only 3 unique type of data set, if you have understood that, type U in the chat box. Yes, okay. Vinita ma'am asks, what is top? Right, so now let me see the same without yeah, so I guess because when we have excluding numbers, ma'am, now what we have highest and lowest, right? Max and minimum when it's a numeric data. So I feel here the top is something analogous to that, where I'm not completely sure here. I'll also look into that and come back on it. Let me make a note of that. Cool. Yeah. Yeah, the first and last are very, straightforward. They are first and last values, right? When it comes to, see, this is the first time we are describing for excluding the numbers. So I'm also not completely aware on what are these, because my focus on was more on to the regression portion, right? Cool. Yeah, thanks, Ritesh. Now I would also go ahead and do it. If multiple object values have the highest count, then the count and the top results will be arbitrarily chosen from the among those which with the highest count, right? So that's what you will see the value of a person in the name column and their counts. Top gives the highest counted value of the categorical values. So we are sure that this is a categorical value, and top is giving the highest counted value, right? So if we see that this has been counted the highest ones, so I'm assuming that should be right. Most repeated value. Thank you so much, Venkatrao. So surely I go back and so top is mode. I'm not sure. So I'll just go and see top is. Great. I'm getting the brief assessment by my quick search here, but yeah, I'll be sure in my upcoming one. Cool. Now we have understood that interest has 3 unique values, and now we are based upon that we are going deep into that. Now you see that in the training data set, interest level, and we do the value counts. Now what this does is it tells us the 3 categories that were there was low, medium, and high, right? So now out of that, low values were 22,000, medium were 7,000, high were 2,000, right? So this is some interesting data that is coming in. Yes, thank you so much, Satish. I'll do that. Right. So now we have understood, what the interest level is meaning, and we'll try to see how we can work around this interest level. Right. So that is clear. Now what we are going to do is look at the mean of the price, because we always want to see whenever we are creating a model based upon one feature what is affecting, and it might be affecting the price. Let us go ahead and see what is the mean price, right? So the mean price is 3,575, right? It could be in dollars. So that is the mean price. Have price here, and the average price of that is coming to 3,575. Okay. Now what we are doing here is we are grouping interest level and price and seeing how each of these are coming together, right? So what we are doing first, train dot group by interest, and then along with that we are getting the price mean and sorting that by values. So what this does is it tells us out of all the lows, the mean price for all lows is 3,800, high is 2,700, medium is 3,100. So wherever the interest rate was low, there are more observations, meaning more purchases could be, right? Because the interest rate for them was coming at a lower rate. There are more people who have taken a decision, okay, I'm getting a good interest rate, I'll go and take the apartment or purchase that. So medium, still there are a little higher, but whenever there was high, there are still a few people who have made a decision and went ahead and made that buy or purchase decision, right? So if you have seen what we have done here, based upon the assessment coming from the describe, we went on to in depth of what these 3 could be, and we tried getting a smaller insight of how this interest level could be having an impact on the price, right? Or the average price for the purchase, right? So is it clear till now? If it is clear, type C in the chat box. Thank you, Venkatrao. Great. So now we have worked with train, going ahead with that. Thank you so much, ma'am. Okay, so let's go ahead and see what we'll do with this interest level, right? So what and what does it do with this one hot encode that was there in our agenda? So interest level seems like a useful predictive feature, but it's a string, and our scikit-learn models expect all inputs to be numbers, right? So that is where this one hot encode comes. Now, what this does is whenever you have high, medium, low, it is going to convert that into whatever categorical data you have. It is going to simply convert it into a number series or numeric data, right? So it is going to do the interest level high, interest level medium, interest level low. So it will make two new columns, like three new columns, and call that high, medium, low interest rate. And wherever it is high, it is going to say 1. Wherever it is medium, it is going to say 1, and wherever it is low, it is going to say 1. So now you know that if you have columns like this, now you can see wherever the column interest rate low equal to true, how are the observations? Wherever interest low is medium, how are the observations, right? So because we are doing this sorting and searching, you can still do it with the interest level being categorical. But if at all you want to perform any of the scikit-learn regression models or other models, you would require them to be numbers. And for that, we use this one hot encode, right? So we'll see this in action, how this is converting all these categorical data into this sort of a layout, right? So now here a few, keywords. Whenever you see the cardinality, that means the number of unique features that particular unique values that a feature has. For example, if we have one column which has let's say small and medium, right? So the cardinality will become 2, the count will become 2. When we have high, medium, low, the cardinality is 3. 2 BHK, 3 BHK, 4 BHK, the cardinality is 3. So whenever you see the unique values that a feature has, the number of unique values it has is always called as cardinality, right? So goes by the dictionary definition, right? So if that is clear, type C in the chat box. Cool. Thanks, everyone. Now, okay, let's continue. Now, what we are doing is we are creating a data frame. We are saying we are setting it to price. And first thing, the other non-numeric columns have high cardinality, right? So this is what we have seen, right? If you see the cardinality here, in address and description and date was high, cardinality is high, and the interest level had very low cardinality, which helped us in going after that. Great. Now we are continuing from there. Now what we are trying to do is for our model, we are going to select a few features, right? Out of that, we are going to definitely have price as our target. If you remember target for the Y axis, we are going to use target, because the impact of others will be there on target. And now what we are doing is the high cardinality number, the features that were there, which were display address, street address, description, and created. We don't require these, right? So now what we are doing is we are dropping these columns from the features, right? So from all the features, basically features are nothing but all of the trains data frame with columns where we are dropping target plus high cardinality. So basically the price and the high cardinality are being dropped from the features, right? Yeah, so basically our scikit-learn or most of our NumPy functions work with our numeric data. So any which way, if you have that in your input, whenever you're giving to your scikit function, any of the function, it is not going to help, right? So because if you see the data set, will not be able to perform any assessment based upon various different description. So we would want something like the price something like maybe bedrooms, bathrooms. This is something that might affect our target or affect our value, but here we'll not be able to make much out of it, right? So that is the reason we are excluding these from our data set, from our features, right? So because it is easy for us to take the value from here. Okay, so I hope that makes sense. Correct. Yes, yes, sir. So basically, we are at this moment manually removing that. Maybe there should be some method, or maybe what we can do is we can always define our own custom method which we can reuse, right? So yeah, we can have the decision making more intuitive and numeric based. We do not want this to be affected by some columns or observations which are not actually adding value, right? So it is simple. Like for example, if you have the same written in text, which is our apartment has, let's say there is one column which says description, right? And it says the bedroom 1.5, brand new 3-bedroom 1.5 baths. Now this description is not helpful, but bedroom 1.5 is helpful. So bathrooms 1.5 is helpful, 3-bedroom is helpful. So we do not require the description. So if you are writing and describing it, it is not useful for our model. But if you break that 3-bedroom 1.5 bath into columns, it is useful. So that is the reason we are dropping all these street address and all those things. Thank you. Thank you, sir. Cool, right? So now we are here. One hot encoding. What kind of encoding would we use if you want to manually encode? For example, we manually encode A as 1, B as 2. Okay, Ritesh, even Jay sir explains this in the sessions. He talks about cat code. So what this does is, like, it's briefly being explained. Where you can look at it at your time. What we are doing is, whatever categories we have, we are just trying to number by ourselves, right? So now, like as you said, wherever A is there, you want it to be 1. Wherever B is there, you want it to be 2. We are just manually just going to say, wherever there is high, mark it as 3. Wherever it is medium, mark it as 2. Wherever it is low, mark it as 1. Instead of automatically having it into 3 separate columns, 0, 1, 0, 1, right? So you can have your own encoding, right? So that is where this cat coding or categorical data coding comes handy. But we are not going or doing this manually, right? So another important point that Jay sir also explains is, and when it is zeros and 1, it is faster in terms of processing, because when it hits the RAM, it is binary and it becomes easier. Whenever, it is binary. Whenever it is 2, 5 or anything like that, so very nominal difference, but I hope that helps. Cool. Now, so we have our target separately as target and features as features, right? So features are all the columns where we do not have the target, along with the high cardinality categorical data, right? Okay. Yeah, thanks, Hitesh. Now, like whenever we build the models, we have our X-train, Y-train, X-test, Y-test, right? So we have for both of these, we are having it. I think that's a very good question. Vinita ma'am asks, can we go for 3 as 0, 1, 1 or 2 as 0, 1, 0? Yeah, where we ourselves are converting it into binary and giving it. Yeah, so as long as it is helping us make a decision, you go ahead and manually label it as 0, 1, 1 or the 0. I mean, you can convert your decimal number into binary, but if you're able to achieve it with the number as it is, like with 3 and 2, instead of converting it into binary, if you are still able to achieve it, you need not have to take extra effort of converting it manually by self. Yeah, thank you so much, ma'am. Cool. So now we have our extreme, where it is taking the features of the train, whatever we have in our features, which does not have the target and the these categories. And train is nothing but the target in that particular train. So just be sure target is nothing but price. So Y train is going to have train of price, right? So the price column will be in Y train, and the price column will be there in Y test, right? So test and train are the data sets which we have used for separating our model, observations for the model, right? Whatever is over 2016 June is going to be in train. After that, it's going to be in test, right? So now we have our features and target. Now we can go ahead and do our encoding and then go for our model fit and everything, right? So yeah, so if at all we want to see the X-train shape, we'll just go ahead and see that. Now you can see that right now there are 35 columns and 31,000 rows in this, right? So this is what we are seeing right now. Now what we are going to do next is go ahead and see, we are doing our encoding and see if it is the same thing, right? So if there's any change in the shape, right? So to do your one hot encoding, you have to import category underscore encoders, right? So if at all you are stuck anytime, you can just Google the library for one hot encoding, and or you can always remember the category underscore encoders. And you are encoding, you are using the alias CE for this, and you're using the variable name encoder saying CE dot one hot encoder. Now CE has the function one hot encoder in that, and then you are using the parameter as use cat underscore names as true, right? So basically you are giving the category names here, right? So now this is what we are doing, and we'll try to first also print the X-train here and see what it is looking like, right? So now earlier we used to do dot fit on the direct train, right? So we were doing this dot fit, but you can also see there is this another function which is fit underscore transform. What it does, it fits to data and then transforms it. Fit transforms to X and Y with optional parameters. Like if at all you have any optional parameters, it does. So more or less, it does a similar operation as fit, but just to introduce that function, that fit underscore transform also has been introduced. You can search, know more about it when you hover on the function, right? So we are using encoder data frame over that fit underscore transform with the input as X-train. Now X-train should have the new encoded 010 kind of a data set. So I'm just going to print that. Okay, cool. So now what I'm going to do here, just for our, being clear, I'm just going to first search for where we have our X-train. Yeah, so we have our X-train here. For now, what I'm going to do here is I'm just going to say X-train before. Okay, I'm just going to add it, run it. Hey, did I miss anything? Okay, so cool. Yeah, so what I'm trying to show you here is, because whenever we do a run of the whole program, the newest data is saved in that particular variable. And for that reason, I'm just trying to go top and change the variable names so I can show you the difference, right? Okay, so I'm just going to refresh this page. Let me see if that helps. I'll see if did it run already. Cool. I think it is still running the same way. Okay, so there's no confusion yet. I'm just going to see if this is working or not. So there are a lot of changes that have been done here. Cool. Do not worry. I'll come back to this. So what happened here? Okay, so I think I have a better way. So let me go ahead and do this. I'll take the original file where we have not made any changes. I'm just going to come manually, right? Let it connect. Okay, so yeah, so there's one challenge when you do runtime and run all. Do not always try to do it. There's some issue that you might run into. Okay, so I'm just going to show you what is that. Right, so I'm manually going ahead and running each of the function. Okay, cool. Let me go ahead, comment this. Great, okay. This is not required. These are all things we have seen. If these are all values we are taking. Okay, this is going to run target. Now here, let me just see if I can do before. Okay, xtrain is going to be the name of the variable, train and features. Okay, so it has run. Okay, now I'm going to see the xtrain shape here, right? Xtrain underscore before, right? Cool. So what is that I wanted to show you is, yeah. So in our run here, before we did our one hot encoding, where is our one hot encoding? Cool, yeah. So before we did our one hot encoding, the number of columns that were there were 29, 31844 observations with 29 columns, right? So whenever you did the one hot encoding, meaning this process, right, there are 3 new columns that got created. Let me explain this. So earlier there were 1 column which is high interest level, then 3 new columns got added, underscore high, underscore medium, underscore low, and that is the reason it changed from 29 after we run our one hot encoder. Yeah, so I think, yeah, I have to update the before and after one, right? So just I'm going to say after, just going to say before. We'll see if this works. Okay, run it. Yeah, so now if you see, earlier there were 29 before, and the xtrain after is 31, right? So how many of you have understood what has happened here, right? Thank you, Ritesh. So now what actually happened in this file is, because you have run everything, what happens is the latest value, what is there in xtrain, because the names of the variables are same before and after, it is going to actually show the same number always, right? So there are a few other operations also we have done in our data set here. For that reason, we have more columns because we did our features and all, but I wanted to show you this one hot encoding, the effect of one hot encoding done here, right? So if it is clear for everyone, that is fine. Thank you, Ritesh. Thank you, Vinith. If it is not clear for anybody else, you can let me know. I'll explain that once. Cool. Okay, I understand that as clear. Okay, so I'm just going to proceed here itself. Let me see if this error is resolved. Not yet. Cool. Okay. So I'm just going to use the same file. Okay. Great. Now, I think here, if I run all, now it should not be a problem. Let me check. Let me know if you are running into similar error in your file sets. Right. Okay. Yeah, now it is cool. Okay. Yeah. Cool. Okay, so now we've understood that the one hot encoder gave us 3 new columns, increasing the shape there, right? So we have understood that. Now so earlier the shape was okay. Now it has come. The shape was this, and after the one hot encoder, the shape was this. Okay, this is cool. Now out of that, what we are doing is similarly we are using the encoder dot transform with the x underscore test. Now we have given the x underscore train. Now we are using the old x underscore test to have a new data set x underscore test. So we are reusing the same data set. The shape will change. Yeah, I'll definitely go ahead and show. X train, right? Okay. Yeah, so that is actually something it is already done here for train test. Okay, so we'll also do it for train. Cool. Let's go ahead and say x, capital X underscore train. Okay, so now you can see that interest level high, interest level low, interest level medium are also here, right? Yes, thank you so much. Thank you, sir. Thanks. I would have missed it if you're not asked, right? But similarly, it was actually done on the same file on test. So we were anyway going to see that. Now, wherever it was medium, it was going to be here. So successfully by using one hot encoder, what we have done is changed a categorical separate column into 3 separate columns with relevant data, right? So this is what was the use of encoder. One of our agenda point is complete, right? Okay, we are on time here till here. Great. So similarly, we have done the same thing for test also. Now test also has been one hot encoded, right? So now this is all we have done. Yeah, so as I've told, madam, fit underscore transform or transform in this case is going to work similarly. Even the function definitions do not heavily vary. So even Jaser explains in the session that there are multiple functions which achieve the same thing, right? Some are in NumPy, some are in Pandas. Names and usage is different, but yeah, you can definitely go ahead and use the same. It was a way to introduce fit underscore transform or also to us. Great. So now we have covered all this. One hot encoder is clear. So if one hot encoder is clear, type C in the chat box. Yes, thank you, Vinita. Great. Thank you, Ravindra sir. Thank you, Ritesh. Thank you, Venkatrao sir. Okay, so now we come to feature engineering. So we'll understand a little bit about feature engineering, and then we'll conclude today's session and pick up tomorrow in our next session from where we'll leave today. Okay, so previously vaguely we might have understood about feature engineering in one of our sessions where we were creating new features based upon a few existing features, right? So we were doing that. So now let's say some machine learning projects succeed and some fail. We make the difference. Easily, the most important factor is the features used, right? So some people to code, right? So they have always had the emphasis on features. Coming up with features is difficult, time consuming, requires expert knowledge. Applied machine learning is basically feature engineering. So which, here Jason is trying to tell us that this is something very important. Feature engineering is the process of using domain knowledge of data to create features that make machine learning algorithms work, right? So what happens is if we know that you can combine a few features to create new features, that is good. But what to do when you do not know what features could be the most important, right? So then you cannot always randomly guess, right? So feature engineering has one of the function of the scikit-learn tells us, what could be the best number of features that you could use, right? So that is select k best, which is also we are going to explore about that. So for example, if there are two features, let's say living room SFT, bedroom SFT, kitchen SFT, you have all of it. Now a simple SFT total, like you can have a total SFT, which is a summation of all of that. That is like a very basic way of creating new features, which you can use in your models. But how do you know what are some most important features without, like, where you are not able to come up with an assessment? So that is the challenge that we are trying to address here. So now, how do we select the best features when you have univariate, like a single variable kind of a data set, right? So this is where we'll try to understand scikit-learn's select k best transformer. Later we'll use another technique, permutation importance. We're not covering that today. So there are in the same exercise notebook that I have given, more inputs are there here. You can read about all of them to have a better understanding for the same. Right? So members who have recently joined, do not be overwhelmed. We covered a few of these previously. Once you come from the beginning, it starts becoming more and more clear, right? Yeah, thank you so much. So general recommendation given here is predictive accuracy on test sets is the criteria for how good the model is, right? Because not going by codes now. Cool. First, let's engineer a few more features to select from. There is a partial example solution from the previous assignment, right? So now if you see, there is one function that here we are creating to create a few features by ourselves without using any of the inbuilt modules or functions, right? So we are creating a new function, which is engineer underscore features, which will take X as input. We'll also define that, the data frame. Now, whatever function we are going to create for the new members, we use def as start of the function, then name of the function, then the parameters or arguments. You will see all of this in your initial sessions. Then here goes the function definition. And then this is the function header. These are your return statements. Okay. Now, what we're doing here is whatever X data frame that comes as an input to the engineer features custom function that we are creating, we're going to create a copy of it and work on the copy, so that we do not want to work or update the actual database. We can always work with the copy. So we're making a copy of it and working within the function and returning that particular function. So the actual original data frame, whatever is being passed, is not being tampered, right? So here, if you see the data set, what we are working with here right now is the same data set which has columns elevator, cats allowed. Let me just see if this is the same data set. We are here, right? Okay, so let me just see. EF dot is, let me know, is this the same? COLUML? UMLS. Cool. Okay. Thanks, Ritesh. Cool. So it has these columns in it, bathrooms, bedrooms created. Now you can see what all things we have. Dogs allowed, cats allowed. All of these columns are there in the data frame. So now what we are doing here is we are trying to engineer a few features by ourselves. So we are creating per columns wherever it is like a good to have kind of a feature, where elevator, cats allowed, hardwood floors, dogs allowed, fitness center. These are all what amenities, extra amenities, terrace, wheelchair access. These are all. So we are creating a new column, let's say perk column, and then we are saying we are creating a new column name called perk underscore count, saying the whatever columns are there dot sum axis equal to 1. So access equal to 1 means create a new column with name perk underscore count. So what it is doing is wherever there is some value like zeros and ones, elevator 0 means no elevator, cats allowed 1, hardwood floors 1. So all of this being added, all the perks now will be saved in the perk count new column, right? So we are creating a new column which is going to have all of the summation of perks. So if at all you want to just see that column and see, okay, there are more perks or amenities in this particular features or flexibilities in this particular apartment, you can make a decision, right? So this is like a fun exercise that has been done previously, where you are using perk count to create a new column. So are cats or dogs allowed? So now what we have done, we are creating a new column name saying if cats allowed is 1 or cats dogs allowed is 1. So any of these is 1, then create a column cats or dogs and say 1 in that. Create a column cats and dogs, and whenever both are 1, then make it 1, right? So x rooms is equal to bedrooms plus bathrooms. So x rooms will have if for example 3 bedrooms, 1.5 bathrooms or 3 bathrooms, then 3 plus 8 is going to be 6. So the number of rooms will. So you have created new columns, but these are like fancy columns, right? You do not know how much of this is going to be impactful or based upon your gut feeling and understanding of the subject you're going to create. So now then return X. So whatever input you give, be it train or test data, engineer features when you give as an input, the new data frames will have these columns also. Per count, cats or dogs, cats and dogs, rooms, right? So if I run this and then do our x train dot columns. Yeah, so now you can see that the new columns that were created, the per count, cats or dogs, cats and dogs, rooms are also created, right? So how many of you understood if you missed the previous? Yeah, so the perk count column is nothing but all the perks calculated, right? Cats allowed is 1 perk, 1 benefit. Perk is here benefit. Dogs allowed is 1 benefit. Doorman is 1 benefit. Dishwasher is 1 benefit. So all of those benefits, some of that is being saved in the perks column. Yeah, so when we say axis equal to 1, it says go ahead and create a column. Axis equal to 1 creates a column. So whenever we are doing a column operation, we try to do axis equal to 1, sir. Great. Thank you so much, sir. So now you can see that these new columns created per count. So now you can see that out of these all, this one particular apartment has 9 perks in it. So maybe it might be a cool place to be in. Sorry. Right. So the perk count has been mentioned here as well, right? So that makes sense. Similarly, cats and dogs, rooms, all of this are also based upon the new features that you've created. So if you've missed the feature engineering functions or whatever, whenever we discussed feature engineering, this is what feature engineering is. You are going to come up with your own columns based upon whatever existing columns you have, right? So cats or dogs, if it is true, means either cat or dog is allowed. When cats and dogs is true, both of them are allowed, right? So that is how it is. The rooms is nothing but sum of bedrooms and bathrooms. Maybe if at all you want to do a calculation on number of rooms alone, that you can use those columns, right? So it sometimes helps whenever you feature engineer or create a new feature, you are going to use that in your modeling to make it easier. So this is about feature engineering. But how do you know what is the optimum amount of features that are required, especially in an area where you do not know the subject? Here, even it was easy, right? Perks or rooms or cats or dogs, it was easy to do, right? So we're going ahead and trying to see could we try ever possible feature combinations? So how many features could be done is what we are going to try to do now, right? Okay, so if you have understood till now what is feature engineering, if you understood that, type C in the chat box. Yes, Venkatrav sir. Thank you, Ritesh. Thank you, Vinita. Thank you, Ravindra. Now, if at all you look at the number of possible feature combination, right? Now, if you see here, what was done is cats or dogs, you are able to combine and create new columns. Now, if you look at how many new columns can be created, given you have 35 columns, right? So because now you have 35 columns within your whole data frame, how many combinations do you think we can make? Right. So that was one question even Jason asked, even that fascinated me as well. Right. So now let's say the features, whatever are there in Xtrain, if we are trying to see the length of that, we have 35 columns in the features. If at all we want to make a new feature, if you want to engineer new feature, how many combinations we can make? So Ritesh, as you say, 35 factorial, it's also below. And how big the 35 factorial number is, just for assessment. So like a fun exercise, it's also been done here. Now you can see that we have imported from math library factorial, and we are doing the factorial of 35 here and seeing how many combinations could be made, right? So I'm just, I think here we have, I think it's not 35 factorial, Ritesh, it is N35 CP, like I think something like that. So let me go ahead and see what was the actual. So let's see the function definition. So now what we are doing is n choose k, passing n and k as inputs. What we are returning is factorial divided by factorial k into factorial n minus k. So I think this is NC. Okay, so I think, let me go ahead and see the permutation formula. Permutations formula. Yeah, I think let me go ahead and share my screen. It's not 35 factorial, it's a combination. Yeah, I hope my screen is visible. Yeah, so it is NPR, n factorial by n minus r factorial, when n is the number of objects and total number of objects, r is the total number of objects selected, right? So now what we are doing here is we're trying to assess how many combinations like that could be made. And now we can see. So now we can see when we are passing in n and k in here as an input, you can see what is n. N is given, and k here is factorial k and into. Let me close. Yeah, so I'm not completely sure what k we are doing here. Any idea, Ritesh? 22. I'm thinking that both of them could be 35. Okay, let me just say factorial of n, factorial of k into factorial of n minus k. N factorial by k into n minus k factorial. Yeah, I think this is what is the formula. So not the permutation. This is the number of combinations that could be made. Total number of objects in the set and total number of choosing objects from the set, right? So this is the actual formula. Yeah, Ritesh, same here. K ranges from 1 to 35. I think Amit has come to our rescue. Okay, K ranges from 1 to 5. I'm not going into the detail of it. It was supposed to be a fun exercise. So thanks. But you can see that the exercise turns out to be this. You can make roughly so and such huge number. Let's say 343 CR combinations can be made, right? So you can see the magnitude of how many combinations you can make. Yeah, so I'll also work on this and maybe clarify in our next session tomorrow. But you can see that so many combinations could be made. Like the number of each column adding up is going to give you more combinations to make. So how do you feature engineer them? Right. So we can't try every possible combination, but we cannot actually do that. For example, we can use univariate statistical tests to measure the correlation between each feature and the target and select the k best features, right? So this is what our function does for us, right? Now, a reference link also has been given. You can go and understand more about the select k best. But what it is going to do is select 15 features that best correlate with the target. For example, the target is price. We are going to select 15 features that are going to be best, having an impact on the target. So now 15 is an arbitrary starting point here. You can have your own. Now select k-best has a similar API to what we have seen before. Dot fit transform on the train set and dot transform on the test set. We are doing that. Now, the sklearn.features underscore selection library using importing select k-best function and the f regression function, right? So we are creating the name we are using the name selector for the data frame selector and using the function select k-best and then passing in these parameters like score underscore function with f regression as an input. Like this is more of a syntax, right? So passing in k as 15, right, to start with. Now what we're doing, x train selected equal to selected dot fit underscore transform, right? On the train we are doing the dot fit underscore transform, giving x train and y train basically features and target as an input to our data frame or the function, right? So when we run that and see what we're able to run and try to print the shape of it, right? So now we have, if you see the train selected has 15 columns and the test selected also has 15 columns, right? So now we are going to see what features are listed here, which features were selected, right? So selected underscore mask, name of the variable, selected dot get support, right? So this is also part of the syntax. Whenever you are trying to assess what features were selected, these are the steps that you have to follow. These have been even not deeply explained by Jaysar here because we are going to read about it as we proceed forward. Correct. Yes. So yeah, so we're going to check that, like, how much impact each feature could have on target. So that is what selects these features, Ritesh. Vinita ma'am asked, what is the F function in the regression? Clearly, so I'm aware about the application, but not what has been behind the scenes here, right? So there could be multiple things going behind. So my closest guess would also be in same, Ritesh, but we'll have to actually go deeper to understand in practical what is that. Yeah. Yes. So yeah. So what Vinita ma'am asked is the F function. F underscore regression, ma'am, you're asking about what is F underscore regression? Like has been explained, I would also be trying to go ahead and define univariate linear regression tests running F statistics and p-values. Okay. Quite quick linear model for testing the effect of a single regressor sequentially for many regressors. I think this is something I would also. Correct. Select k best parameters are going to be the same. That is part of the syntax for us to do a selector. More of it has not been put up in the scope of this notebook. So I'm also with that much information. Cool. Great. So now what we're doing here is definitely maybe tomorrow I'll be able to work on that. Yes, Vinita ma'am, select k best parameters. Okay. So what we will do is we'll first today we'll try to understand the application part of the select k-best features. Tomorrow, because we'll have a session tomorrow, I'll go deeper, understand, come back on all these, select k-best, because I also got limited time to work on this particular function. So I'll also spend more time, understand it, come back tomorrow, right? Also, Venkatrao sir, on all your queries as well. Great. Okay. So now, basically, I'm just going to search and understand, right? So that's what I'll be doing. So now what we are doing is all names of the columns taken in the variable all names, and the selected names are going to have whatever we had in the selected mask. So this is going to give us whatever columns have been selected. The unselected names is all excluding the selected mask, which is using the negation or the tilde sign, right? So now these are the variables that have been created here to save the names of the columns, or to know what column names are selected and not selected. We are going to print all the selected features, because this is going to be a list for we are just going to run a small for loop for name in selected names, print name, right? So how many ever names are there in selected names, all of them going to get printed. What are there in the unselected names are all going to get printed, right? So maybe perhaps one of the questions that could be partially answered of Ritesh, the K features, what are parameters the selected? Basically, if you have seen the function definition of f underscore regression, maybe your guess could have been closer, like the f statistics and p values, right? So basically, the p values based upon that, what affects the target, what feature affects the target best or highest are being chosen, is what my current case would be. Yes, Vinita. Right. So now if you see the selected features are these, which are having a higher impact, the top 15 features which are having an effect on price are these, right? So now if you see the perk count also came in this, right? So more perk count were there. That's also helping a person to, the increase or decrease the price, right? So yeah, makes sense. So the top best features are based on p-value. Right, thanks, Ritesh. Right, so now if you see what features were affecting price based upon the select K best model, number of bathrooms, bedrooms, the longitude, meaning basically the location always interest level high or interest level low. Okay, those are also affecting, because yeah, we could see that price was fluctuating between that. Elevator being there, yes, dishwasher, terrace, and outdoor space, and all these things are helping. What are not helping? Now it will make sense. Okay, laundry in building not helped, cats allowed not helped much. Okay, cats or dogs, and cats and dogs, the functions that we created, the features did not help much affecting. We are not saying that these are not helping, but these are not the top 15 parameters that are helping, right? So we are not saying that these do not matter. These matter less than the top 15, right? So the roof deck, balcony, and interest level medium, because high and low had higher fluctuation. So this is what we were able to assess, right? So I hope the select K best features made it clear on how to select the top features that are impacting the price, right? So if this is clear till now, given all the questions specific to the syntax or use of the parameters, we'll take them tomorrow. If you understood the application of it, type C in the chat box. Even people who have recently joined, if you understood the application of it, type C in the chat. Thanks, Ritesh. Thanks, Venkatrao. Thanks, Vinita. Yeah, so we will be, concluding our session till here, covering till here. Tomorrow, we are going to see more of this particular exercise. And out of that, what is the optimum number? Right now, we have selected 15 as an arbitrary number. So how can we select an optimum number of features, right? So is out of 35, is it 20, is it 21, or is it lesser? So how do we select that also? We'll check tomorrow, and rest of the other portions of the exercise. I'd highly recommend you to go through Jain sir's session. If at all you would want to cover it beforehand for tomorrow, that's also good. Great. So people who have recently joined, if you're still, here, also trying to understand or digest what is happening here, thanks for being here. Thank you, Venkatraw sir. Venkatraw sir says, thank you very much. Have a happy weekend to all of you. Cool. And thank you so much, Deepti. So members, definitely go ahead. And if at all you have any queries, even from the beginning sessions, go ahead and bring it to us. Yes. Thank you. Thank you, Ramesh sir. Thank you, Deepti ma'am. Thank you, Ritesh. Thanks for helping as always while asking questions. Great. So see you all in our next session. Have a good one. Bye-bye. Thanks, everyone. Thanks, Randa sir. Thank you, Amit sir. Thank you, Vinita ma'am.